Hello everyone, thank you for watching this talk. It is my pleasure to be presenting today in the joint track on software engineering education and training. I am Miguel Morales from the University of Canterbury in New Zealand. Today I will present a paper titled Learning Software Quality Assurance with Bricks. As you may know, teaching software quality is a very interesting task because even if quality is a common word, that everybody uses it and we can recognize quality when we see it, it is very hard to explain. And just because quality is purely abstract. The problem for software development is that it must be instantiated in some way in order to be demonstrated. So software quality is crucial for software engineers because we have to show that our processes and products are suitable and they conform to the specified requirements and expectations from diverse stakeholders. It is here where software quality assurance and software process improvement topics become relevant and come into play. And literally into play because we use Lego bricks to teach software quality assurance and software process improvement. Both SQA and SPI cannot be taught by applying a single standard approach or a single set of common procedures. Students need hands-on experience with practical scenarios in order to understand the consequences and the effects of applying or misapplying these techniques, these practices. So this was the motivation for creating a hands-on activity that aims at understanding and applying SQA and SPI concepts and techniques while participants build objects and assess their quality based on metrics associated to specific quality attributes. The name of this activity is KUALI-Brick. But before going into the details of KUALI-Brick, I would like to present some related work with these two word clouds. On the right side, you can see the most recurrent topics presented in the papers that we found after performing a literature review in order to understand how Lego is used in software engineering education. Out of the 16 papers that we identified as relevant, 4 are about Scrum, but also XP, TDD are agile frameworks that are mentioned or are recurrent in the papers we found. In addition to the agile frameworks, also several core software engineering topics are taught through hands-on scenarios such as requirements engineering, risk identification, project planning, change management, and estimation techniques. On the left side, you can see the means that the researchers used to validate or to collect information about their proposals. Survey is the main mean for collecting information, for validating what they are creating. But let's go back to KUALI-Brick. KUALI-Brick in particular is an activity that is being carried out in a 4th-year elective course for software engineering and computer science students. The course is called Ceng 403 Software Process and Product Quality and has been taught at the University of Canterbury in New Zealand since 2018. The course introduces software quality key concepts, practices, methodologies, and techniques present through the software lifecycle, and it follows the 4P approach. It is, we analyze quality from the perspective of the people, the process, the product, and the project. Particularly relevant are the process and the product perspectives for KUALI-Brick, which is an activity, a Lego-based activity that which objective is to build a Lego city within a fixed amount of time and obtaining as many points as possible. In a nutshell, the KUALI-Brick session is designed to be carried out in 100 minutes and consists of 3 to 4 iterations. It has 3 main stages: the setup and presentation stage, when the instructor has to arrange the room, set up the materials, presents the generalities and the rules of the activity, divide the students into teams, And this stage it's followed by the building and assessment iterations. Here you can see, well, the blocks organized, the bricks organized in boxes. Also, with letters, you can see the safe pockets that contains the instructions for building the figures, 4 per team. And the figures are a vehicle, a building, an animal, and an object. Students have to allocate points to each of those figures. The green numbers are representing those points, and those are relevant to determine which is the winner team at the end of the activity. Also, in the envelopes labeled with numbers, those contain the building processes that the teams have to follow, and those processes must be followed during the first iteration, but after that the students have to apply the software process improvement techniques and concepts in order to improve their process. At the last stage, it's the discussion. It's an opportunity for reflection and for wrapping up the activity. Also for discovering which is the team that earned the most points based on the quality of their buildings. During the last 3 years, 68 students have participated, most of them from New Zealand. Based on the results, well, the fun factor is incredibly high, as you can see, but also the learning aspect is relevant for the students. It's important here because students feel that the activity is connected to what they already know, and it's contributing to their learning. Some effects, positive effects, as I mentioned, engagement, motivation, and fun just go up. They are rated very, very high. The hands-on approach and the abstract concepts made concrete are also advantages, positive effects of this activity. Some stress levels have been identified on some students. That's a negative effect, but they are completely surpassed by the positive aspects. Time constraints and costs are also relevant because this activity, the effort and the cost, it's not cheap. What we have learned from here, well, discussion is fundamental at the end of the activity. Students need this opportunity to reflect on what they learn. You have to make the most of the fun burst because it lasts beyond the actual activity. The students keep engaged with the course after the activity. Avoid branded sets. We have found that the classic set is the best one, so avoid Lego Star Wars or Lego Friends for this activity. Some of the limitations of this activity is the lack of a formal assessment. We don't have the means yet to assess the knowledge of the participants if they learned something, but well, it's a future work. And also the Lego metaphor, it's not a substitute for the actual software development tasks. You should be aware of that. This is just a simulation. Well, students should be aware of that. This is a simplified version of the development process. As conclusions, we can say that the knowledge acquisition is fundamental, but there are other aspects that can affect that knowledge acquisition. And fun and engagement, it's a very important one. It affects in a positive way the knowledge acquisition in this case. KUALI-Brick has demonstrated to be an excellent tool for making fourth-year software engineering students aware of how abstract concepts can be instantiated into concrete objects. And in general, we can say that the mix of software engineering and Lego are a very successful mix. It secures a superb learning experience and turns very high the engagement, the enjoyment, and the fun. Still, we need a mean to validate that students are improving their learning. Well, as future work also, I want to make available the rules and the steps of the activity to obtain feedback from the community. So thank you very much. This was KUALI-Brick, and feel free to ask any questions. Thank you.
Okay, hello again. So we are here in the second paper of this session. Miguel Morales from the University of Canterbury is the author, so he's here to answer your questions. So if you have any question, please go to the chat and write whatever issue you would like to be discussed. So in the meanwhile, I have a couple of questions about the paper. So the first question is about the quality criteria that are used to evaluate the students' work. So are these criteria provided to the students in advance so they know before doing the assignment how are they going to be evaluated, or are they just using by the instructors at the end just to measure the quality of the work?
Okay. Well, hello everybody. Thank you, Anna, for the question. No, we don't provide the quality attributes in advance. Students have the opportunity to define them. What we do before the activity is to like a recap of the ISO 25010 in order to remember the model, right? The testability, maintainability, this kind of standardized quality attributes. But the idea is that they have to transfer this knowledge into the game environment now and decide which is the main or the most valuable for the customer, for the user in this case. So I highlight that it's a game. It's the purpose of the thing that, or the object that they are building, it's to have fun, to enjoy a particular use, to provide enjoyment to the users. So they come with ideas like, oh, the level of fun, or how is the structure of the toy, or how many times you can play without breaking it. So they come with the ideas. It's up to them.
Okay. And then the other question that I have is about the quality of the process, because you mentioned at the beginning of your presentation that you try to work with or try to use this idea to measure the quality of the product that the students develop, but also you mentioned about, you talk about the process, the software process improvement. So the presentation of the paper that you have presented is more related to the product that the students are developing and about the process. So how this idea can be used to evaluate the process or to improve the process that they are following.
Okay. Yeah, you're right. The focus of the activity is on the product. In fact, we are giving points to them based on the quality of the product. And I think if we want to highlight the software process improvement, what they need to do in order to make more efficient their process, then the instructor should guide the discussion on this point, because at the end of each iteration, of each phase, they have 5 minutes for discussing what went well, what didn't go well. So maybe it's an opportunity for the instructor to discuss, okay, based on the result of the process in the previous phase, what would you could do in order to improve it? Or what about the definition of the process? It was too strict, or maybe you need more flexibility. We provide 3 definitions of the process based on the roles, on the activities, and a more flexible one. So I think it's up to the instructor to guide that discussion in order to focus on, to highlight the importance of the software process improvement.
Because they choose which is the process that they are going to follow to build the artifact.
No, in fact, it's a random allocation. We put this into envelope, and they choose the envelope, so they don't know which is the process beforehand. But it's random.
But once that they are assigned to a specific process, they are supposed to follow
Yes,
this.
at least during the first iteration. But after that, they can arrange or make the changes or adjustments that they want.
Mm-hmm.
Yep.
And this process that you assign to them, can you tell us how is the process? Which are the main steps of this process or the activities of this process? Do you base on some standard process, or how do you?
In fact, it's very simple one. I based the course in the 4Ps: the people, the product, the process, and the project. So I used that approach, and I said, okay, one process will be defined through the roles. So you have a quality assurance person who will assess the quality of the product, but you have a person who will pick the pieces, the bricks based on the image, and you have another person that will build the actual object. So I define the roles. They have the definition in that particular one. But also I have the activity-based one, the process-based one, and I provide the steps. You have to go and pick the bricks. Then you have to build the object. You have to assess. You have to discuss. And the third one, it's very flexible. It's up to the students to organize their activities, their work. So yeah, I follow this 4Ps approach and define the process based on those.
Okay, and do the students take any measure or about which part of the process is more difficult to them, or if they have a problem in the quality, why is the reason, or how do they analyze the process that they are following?
Mainly, well, in these years of experience, they base the discussion on the actual outcome of their product. So the process is very tied to the product. If they were capable to build the object in a good way, then they won't complain about the process. But if something goes wrong with the actual product, they start complaining about the process. So yeah, it's well, I think it's a reasonable association, but yeah, they focus that discussion based on the quality of the product.
Okay. So we have a question from Max. He thanks for presenting the paper, and he said, "Do the obtained points influence the students' grade? If not, how do you make sure that the students do not only see the activities as a gain, but as a learning experience?"
That's a very good question, because well, this activity doesn't have any influence in the grades of the students. In fact, a limitation of this activity is that we don't measure if they are acquiring knowledge, right? So that I'm developing an instrument to assess if they are learning something at the end. It's not just for having fun. So that's a good, an opportunity of improvement here. Yes, I would say that the activity it's for motivating them, to making them aware that learning about software processes, software quality could be enjoyable, and I use or I take advantage of that motivation, of that level of fun, for continuing to the course and making them interested in the topic. Yeah, if you ask me, well, at the end of the activity, did they learn something? Well, the answer is I don't know yet.
I'm not sure.
I'm not sure yet. Yeah, assessing the change on the knowledge of the students, it's still in progress.
Yeah. Okay. Yeah. This question made also think me, because I have a similar game. I teach an Scrum course, and I use also Legos to teach Scrum. So we simulate the construction of a city and so on. But I don't give points to the students for this activity. So what I try is that they understand the process, and they try to learn and to fix in their minds which are the different activities or the different steps, or where can the problems, the most important issues, where can arise in the process. But I don't give them any mark, or it's just try to learn. And if you ask me, are you sure that they learn? I think that I gave the same answer that you, but I think that they learn. I have not the proof.
Yeah.
But
No.
I intuitively think that they learn, but not sure.
Yes, based on the comments or on the qualitative
Yeah.
feedback, yes, I think they are learning, but yeah, it's still. I need to provide evidence at some point.
Yes.
Yeah.
Sure. Me too. I will think about